Now we need to find the CDF of marginal CDF of x and y. And part A. If my joint CDF looks like this, I want to find the marginal CDF of x. So the marginal CDF of x is just that the joint CDF of xy, the y goes to infinity. I don't want y. So if we have y goes to infinity, that means in here y goes into infinity because exponential part goes faster than y. So those, and there's a minus here, so finally they cancel out to 0. So there will be x minus 1. Because you can think that those should be in the denominator, and when y goes to infinity it will be really, really large, and finally this fraction goes to 0. And here's 1 x is from 1 to 2. And here again, it's 1 when x greater than 2, and zeros otherwise. For the marginal CDF of y, we let x goes to infinity, which means x goes to infinity. X goes to infinity. They still have the same equation because there's no x. X goes to infinity. Here, then there's no x, so I keep here. And so x and f of x and f of y are not equal because they are not they are not independent. F, the joint CDF doesn't equals the individually joint CDF multiplication, so they are not independent. Let's find part B. Again, we want to find the CDF of x, so I need y to be infinity. Y here, both are greater than 0 to infinity. Now I just let y to be infinity. So here I can get 1 when x is greater than 3 for this part. And 2 divided by 7 here in this part when x is from 2 to 3. And zeros otherwise. And the marginal CDF of y, I have x to the infinity, which means x to infinity, so we don't look at this one because x is in here. X here goes to infinity. Finally I will have, because there's no x there, so I have this when y equal greater than 0 and 0 otherwise. And x and y are not independent because this times this doesn't have the same form.